Probably. So hopefully the lunch was reasonably filling, but here with a small additional serving of alphabet soup is our good friend Greg Hankins to present on EVPNs.
All right, good afternoon. I'm going to talk about Ethernet VPNs, EVPN, and give you a little introduction, overview, and kind of some motivation and some things that you can do with it. All right, I think this works. Okay. So if you look at the way that Ethernet services have evolved, EVPN is just kind of an evolution of the way that we can deliver Ethernet services. It's not really a revolution. It's kind of just fixing some things that we can't really do with VPLS or other technologies right now. So first question, why another technology? We have MPLS, VPLS, we have PBB, and those technologies are great. We've been using them for years and years to develop Ethernet services, but there's a couple things that haven't really changed, and that's primarily the control plane. We still rely on flooding and learning in order to build the forwarding database. EVPN kind of builds on all that operational experience that we have with VPLS and introduces a new model for Ethernet services that, again, kind of fixes some things that we can't do with VPLS right now. It kind of works in a layer 3 manner, so it uses MP-BGP to distribute MAC and IP routing information instead of flooding and learning. And it enables you to do a couple new things to deliver Ethernet services, primarily for these applications. Data center interconnect is a really popular one, virtualization services, and also integrated layer 2 and layer 3 VPN services that you can run over the same interface or the same VLAN, whereas before you needed a couple of different technologies to do that. Operational benefits, what does this do for you? What does this mean for you? Integrated services is probably one of the big value adds for EVPN. Like I said, gives you the ability to use one technology to deliver a layer 2 and a layer 3 service on the same interface, whereas before you needed something like VPLS for layer 2 and then layer 3 VPN on top of that, and it just gets kind of complicated. Efficiency is a big focus for EVPN, and especially the ability to do multi-homing. We have this concept called all-active forwarding, which load balances between the PEs, gives you obviously more efficient service delivery, and you don't waste any bandwidth with an active and a standby link. Design flexibility is also a big part of EVPN. You have a control plane that uses MP-BGP, and then under that you have a choice of data plane encapsulations, and I'll go through all the different options in a little bit. And then also greater control. Obviously, if you use BGP to distribute MAC and IP routing information, you can control that. You also have the ability to statically provision or program MACs into the router's forwarding database. We also have this functionality, which I'll go through in a little more detail, that allows the PEs to proxy ARP and ND, so you actually don't have the flooding across the network that you have today. Oh, back up. If we had, this was kind of the technical version. If you wanted to kind of take this up a level, then we would talk about cloud services, and we'd throw in words like SDN and NFV and things like that. But this is the technical slide. EVPN status, it's really a hot new technology in the IETF, and you can see that there's a bunch of different internet drafts. The ones in red have expired, the ones in gray are moving forward, and the ones in green are kind of the ones that are going to be RFCs next. And then we also have our first RFC, which was just came out a couple weeks ago, which is the requirements RFC. So if you look at the drivers behind EVPN, there's kind of a diverse set of network operators and vendors that are collaborating together. So it's not a vendor technology or a single vendor technology that someone's trying to push in the IETF. I really think that it is a collaboration approach to develop the best new technology that we can. From a vendor side, we have Alcatel-Lucent, Cisco, and Juniper, which are on the draft, and then from the network operator side, we have big networks like AT&T, Bloomberg, and Verizon as well. And we also have shipping implementations. Alcatel-Lucent, Cisco, and Juniper are already shipping code, so you can actually get this and deploy it today if you wanted to. Okay, so let's talk about the layering a little bit. As I mentioned, we have the MP-BGP control plane, which is used to distribute the MAC and IP routing information. And then you have a choice of data plane encapsulations, and these are the three most popular ones. If you go back to the slide, with the internet drafts, you can see that there are a bunch of other proposals to add different data planes. So MPLS is in the base specification. This is, I guess, the most popular one. It just runs over MPLS. You can deliver Ethernet services. You use RSVPT or LDP, whatever you have in your network today. You can also integrate it with PBB. This is a scaling mechanism so that you can have PBB on the edge to hide the customer MACs and just replace it with a backbone MAC, so it's a scaling mechanism. And then we also have, I guess, kind of a newer one, which is using an NVO data plane. So this could be VXLAN, NVGRE, or MPLS over GRE. VXLAN is probably the one that's most popular and the one that's shipping today. So control plane learning, as I mentioned, we use MPBGP. We know and love BGP. We've been using it for years and years to do layer 3 IP routing, so now we can use it to do layer 2 MAC IP routing. So you get the inherent scalability of BGP. You could even add route reflection or something like that to build hierarchy. It's designed to support v6 from the very beginning, so there is no, there's no bolt-on or something to do v6. It uses an IP address, which can be an IPv4 or a v6 address, so from the very beginning, IPv6 is fully integrated, so we love that. And the control, I think, is really an interesting mechanism. If you think what we can do with BGP routing policies for layer 3, you can kind of extend that to develop interesting policies for layer 2. This is the alphabet soup slide that Tony mentioned. Unfortunately, I hate showing these kind of slides, but in the short amount of time, we kind of have to just have a couple concepts so that you know what we're even talking about in the next set of slides. So as I mentioned, we have the control plane learning and the data plane learning. We already talked about that. A couple interesting and key concepts that EVPN introduces is this concept called all-active mode. Primarily, it's probably dual homing, but in theory, you could actually multi-home to any number of different devices. And the way that this works is that you just use LACP from the CE to the PEs, and you don't actually need a multi-chassis lag. So this just works with standard LACP, and EVPN actually introduces all the loop control mechanisms and things that you would need so that you don't have looping and things like that. The other key concept is the concept of a CE. This can be it can be anything. It can be a router, it could be a switch, it could be a server with a VM or something like that. It's just some sort of edge device that's connected to the PE. And then there are a couple other terminology things. The EVPN instance ID, that's just the EVI, and then it also has the concept of Ethernet segment, the ESI. So that's just the Ethernet segment that's attached to the CEs from the PEs, and it uses this in the routing information. So a quick introduction to the alphabet soup there. The services, these aren't any new services that we aren't offering today. EVPN decided to just kind of define them so that we're all on the same page for services. So you have your standard VLAN-based service. This is just a pipe from one location to another. You have a bundle service interface, which uses one bridge domain, and then you have something called the VLAN-aware bundle service interface, which actually uses multiple bridge domains. So just defining the terminology and making sure that we have a standard to talk about. Okay, so now you know a little bit about the background and motivation. Let's talk about operations. There's a lot to it. I'm kind of going to skip through these slides in order to get to the interesting part, which is the applications. But EVPN basically has a bunch of mechanisms to make Ethernet work over a wide area network. So we have to do a couple things to control loops and provide for MAC mobility and things like that. And then I'll tell you about the different data planes too. So obviously, when we have a dual path, we have to worry about looping and flooding. So EVPN has two mechanisms. One is to control broadcast, unknown unicast, and multicast from the core to the CE, and then we also have to control it in the other direction. So from the core to the CE, we have this thing called the designated forwarder, and this is a router that's elected in order to forward the broadcast, unknown unicast, and multicast frames. So that way, you only have one router that forwards them onto the Ethernet segment, and we don't get duplication. So kind of the other way around, from the core to the CE, we also have to control loops because we don't want to echo frames back onto the segment from which they just came. So we have another mechanism to control looping from the CE to the core. Proxy ARP and unknown unicast flooding suppression. This is a really important mechanism, so I do want to spend a little bit of time on this slide. But if you think about networks today, a lot of them are static. A lot of them can be provisioned, and there's really no need to have ARP and ND flooding and all this unknown unicast anymore. So it's kind of also a security issue. If you can lock down all the MACs in your network, obviously you have greater security, and maybe you don't have rogue stations coming on the network, or ARP spoofing and things like that. So what EVPN can do is actually suppress or even just completely eliminate unknown unicast flooding through a couple different mechanisms. You have the ability to statically provision the ARP or the ARP or ND on the PE, and then all the PEs can locally proxy for those addresses. So it reduces the flooding to just that local segment. The other thing that you can do is you can have snooping functionality if you didn't want to program all the MACs statically, where it could snoop things like DHCP or things like that, and it would build the forwarding database that way. If you wanted to just provision everything statically, you can completely disable learning, and then you don't have any of those problems. Aliasing, this is kind of a mechanism to control if a MAC is learned on one interface but not on the other. So if you look at this case, if you have a computer or a server or something that doesn't have a lot of traffic, you could have just the MAC learned on one PE. So aliasing allows multipathing on the return, so that you always have multipathing and all active forwarding. MAC mobility is another important one, so I want to spend a little bit of time on this slide. But basically, in a network, MACs move. That's reasonable, and that's completely expected. But EVPN has to have a mechanism to advertise those MAC moves. So what it does is when you have a MAC and IP route, it has a sequence number, and then those sequence numbers are incremented so that you can tell which one is the newest one, and then if there's a MAC move, then it knows which route to use. So kind of as a corollary or function of MAC moves is also MAC duplication. Also, we don't have loops. We don't want to have loops on the network, so we have to have a mechanism to avoid loops. And the way that this works is that there's a timer that is configurable on implementations. And basically, if it sees a number of moves within a certain period of time, then it stops advertising the route and withdraws it. And depending on the implementation, it'll restart after a timer or something like that. You could have the operator clear it. But basically what this does is it provides a per MAC loop control. So this is kind of an interesting mechanism, because today if we have a loop in the network, then generally the whole port gets shut down or the whole VLAN gets shut down or something like this. But this is a per MAC loop control mechanism. Mass withdrawal, this is just really an optimization on withdrawing. So if a segment goes down, then all MACs for that segment will be withdrawn instead of sending several withdrawal messages for each individual MAC. And then default gateway, this is an interesting thing. This is what allows you to do the integrated layer 2 and layer 3 services. There's a draft right now. In the base specification, it supports a default route, and there's a draft right now in the ITF to allow just arbitrary routes to be injected. But the interesting thing is that if you have a data center or something like that, and if you configure the default gateways with the same MAC address, then when you have MAC moves, the traffic is always forwarded to the closest destination. You don't have this situation where you have a station that moves across the network but still has the MAC address of the gateway that's across the network. So you don't want to keep tromboning that traffic around. And then let's talk a little bit about the data planes. So MPLS, as I mentioned, is in the base specification. EVPN is really easy to deploy, by the way. If you have an MPLS network or just an IP network, you can put it on your PEs, fire it up. You don't have to change anything in the core, and that makes it really easy to deploy. So EVPN over MPLS just runs over MPLS. Whatever your MPLS network is today, EVPN will run over that. It supports all the features and functionality that we know and love from MPLS, so fast reroute, traffic engineering, all those kind of things. So just standard stuff. You could integrate it with PBB, as I mentioned. This is really just a scaling or a MAC address hiding mechanism. So you can use the PBB backbone edge bridge functionality to hide the customer MACs and aggregate them with a backbone MAC. So you could do this, for example, if you had very large layer 2 networks and you wanted to reduce the number of routes in the EVPN, or also if you have customer MACs that you don't want in your backbone, you don't want to protect your backbone from customers doing things with their MAC addresses, you could also use this mechanism. And then the last data plane, as I mentioned, that's really popular is VXLAN. So VXLAN is typically kind of started out as a data center technology, but you could absolutely run EVPN just over an IP network using VXLAN as the data plane. So VXLAN, in case you haven't heard about it, it just encapsulates Ethernet and IP. It's a really lightweight protocol. It's I think like 50 bytes overhead or something like that. And because VXLAN doesn't depend on any MPLS functionality, it's, as I mentioned, simple to deploy, and you can deploy it over any IP network, and then it takes advantage of all the IP mechanisms that you have. So, you know, ECMP, IP fast reroute, all those kind of things. And the neat thing is that you could actually even terminate a VXLAN endpoint in a VM on a hypervisor. So you could actually, you know, run the endpoint all the way down to the VM, which I don't think you can do with VPLS today. Okay, let's talk about some of the use cases. These are the most popular ones that our customers are asking us about. Data center interconnect, as I mentioned, obviously is a huge, you know, a huge business with data centers. Layer 2 or Layer 3 is equally easy to do, again, because we're using EVPN. We have the ability to do Layer 3 or Layer 2 on the same interface, on the same VLAN or whatever you have terminating. So it provides all the benefits of data center interconnects. You have the ability to do MAC moves, you know, the programming or ND proxying, all those kind of things. And again, also the optimized routing. So you send traffic to the nearest destination to get routed instead of sending it all over the network. Business services and infrastructure networks, this is kind of from the perspective of you as a service provider. If you had customers that wanted a Layer 2 or Layer 3 VPN service, really easy to do. You can have, again, the all-active forwarding, or if they just wanted, you know, sort of a primary and a redundant connection, you could do that too, absolutely. And, you know, again, any data plane will work. You can use IP or MPLS if you have an MPLS core already. And, you know, it's real simple to provision because you just have that single technology. And then this is kind of from the perspective the other way around. If you were a service provider and you needed to build simple site-to-site networks, well, maybe you're buying transit from a number of different providers across your network, and you know, it's hard to do MPLS inter-provider right now, so EVPN is a real easy way for you as a network operator just to fire up a simple VPN between sites. So you know, it just uses IP, so you can use simple IP routing over any number of ASs, you know, if you have one transit provider or a number of transit providers, and you just set up EVPN, and you know, there's your interconnect service. Okay, summary, EVPN is a next generation VPN technology, uses BGP to distribute the MAC and IP routing information. We have a Layer 3-like operation, so using MPBGP. It delivers Layer 2 and Layer 3 services integrated over the same interface. And you can use any control plane, MPLS, PBB MPLS, or VXLAN. And we have the ARP and ND proxying security function and ability to program the network. And there's more information. I listed all the ITF L2 VPN working group, and then the most important RFC and drafts are there. And wow, that was fast. So I went kind of fast because I gave this presentation at RIPE a couple weeks ago, and I think we had like at least 15 minutes of Q&A, so I wanted to leave some extra time for Q&A in case you had some questions.
So if there are questions,
perhaps we are all tired after lunch.
Food comas may be set in, I don't know. Here's one, at least.
Hello, Brandon Ewing with Layered Technologies. All your slides on the CE showed a single CE at each site when you were talking about the loop prevention mechanisms. Is there anything built into the protocol for loop prevention if you have multiple CE devices for a specific customer in a site?
Yes, so it uses the same mechanism. Because they're all attached to the same, that was the ESI that I mentioned, they're all attached to the same Ethernet segment, so they would all have the same Ethernet segment identifier, and that's what's used for loop control.
Thank you.
Okay, thanks.